Hello guys, today we're doing LeetCode question 733, flood fill. Question is easy and it is, you are given an image represented by an m by n grid of integers. Where image ij represents the pixel value of the image. You are given three integers, SR, SC and color. Now SR represents starting row and SC represents starting column. Your task is to perform a flood fill on the image starting from the pixel, image, starting row, starting column. To perform a flood fill, begin with the starting pixel and change its color to color. Perform the same process for each pixel that is directly adjacent. Pixels that share a side with the original pixel, either horizontally or vertically, are pixels that are adjacent. And they have to share the same color as the starting pixel. Keep repeating this process by checking neighboring pixels of the updated pixels and modifying the color if it matches the original color of the starting pixel. The process stops when there are no more adjacent pixels of the original color to update. Return the modified image after performing the flood fill. So as you can see here, our starting grid is got first row of ones, two rows of 1, 0, 1, 0 and 1. Now you start from the middle position, which is 1, and you change all adjacent ones to the color which is 2. So as you can see, the ones adjacent that match the same number as the starting value, so 1 would be left and top. So now they turn to 2 and this turns to 2. Then you check the adjacent ones of those, 2, 2, 2. But these are 0, they don't match the same color of the starting value, so they remain 0. And this one is not adjacent to any 1 value, so it remains 1. So explanation from the center of the image, or to sum it up, that's what I just said. Example 2, I set all 0, which returns 0. So the way we're going to do this is with depth first search. I'll show you here. So we have our grid. What we're going to do is we're going to check each position recursively. We're going to check that let's say we're given here as a sum, which we are. We check this, 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 and this, and then from there we'll check this. We'll check the values above, beside, below, and to the right. So left, above, right, and bottom. But the first thing we do is we save another variable as starting color. We need to check that they match the starting color. So we'll set it to the current position of starting row and starting column, which is 1, 1, which is 1 here. So we set it to 1. Then we check recursively left. We'll start with left first. So we'll go left. From here, does that match the starting value? Yes. We check, is it in bounds of the grid? Yes, it is. And is it currently the color? The reason we check for the color is otherwise it will be an endless loop. If we check the color and it turns 2, it will endlessly go around. So we check that it's already, that pretty much checks that it's already been visited or not. So now we turn these two to 2. So that's now 2, that's now 2. Then from here, we can't go left, so we go up. That's our 1, same starting value. So we change that to 2 as well. Then we can't go left, can't go up. We go right. It's 1. It matches the start value, so we change that to 2 as well. We've already gone left. 2 is the start value. Sorry, is the color, so we leave that. We go up, can't go up. We go right. Now that's 1. So we change that to 2. We've already gone left. We go up, can't go up. Go right, can't go right. We go down. Now 0 does not match the starting value, so we just return. We go all the way back. Now we're back at 2 here. We go down here. That's our 1. That matches the starting value, and it's not currently been visited because the color is still 1. So we set that to 2. Then we go back up. We're now at 2 here. We go up. We've already gone up. We go right. Right is 0. It doesn't match start color, so we return. We go down. Doesn't match start color, so we return. We go down. So our ending array, image will be 2, 2, 2, 2, 2, 0, 2, 0, 1. So let me show you how it's done in code. Okay, so the first thing we do is we get the starting color, the starting position. So we get let start is equal to the position, starting row, starting column, which is the starting position. Then we have to create a recursion function of depth first search. So function DFS, we pass our row and our column as values. Then we have to check if the position is currently in bounds. So if the row is smaller than 0, we know it's out of bounds. If the column is smaller than 0, it's out of bounds. If the row is bigger than or equal to image.length, we know it's out of bounds. If the column is bigger than or equal to image row.length, then we know it's out of bounds, so we return. Then we check if the current position either doesn't match the starting color, or it matches the color we have to change it to. That way we know we don't have to change that color, or we've already been there. So if image row column is equal to color, then we know we've been there, so we don't have to change it. Then we check if image row col is not equal to the starting value, we know we don't have to change it, so we return early as well. Else, we know we have to change the current position to the color, so image row col is equal to color, and then we recursively check each position. So DFS row col +1 is the right value, DFS row col -1 is the left value, DFS row +1 col is the bottom value, DFS row -1 col is the top value. Then we execute the function DFS, we pass the starting row and the starting column, and then we return the starting image, or the changed image. So image. Let's see. As you can see, that passes. Let's submit. Perfect. As you can see, it's the fastest method, and it beats most people for space complexity. So our time complexity is O of n. As a worst case, we're looping through the whole image here. And our space complexity is O1, as we're storing a constant variable. Thanks for watching.